Okay, welcome back. And now what we're going to do is we're going to do an example of finding or proving the limit of a specific function, one that is nonlinear. Okay, so far the last two were linear functions. How do we deal with something that's a specific function that's nonlinear? Let's see what we get here. So I have this one, so we want to prove that the limit as x approaches 2 of x squared is 4. Obviously we know that that's true, but let's prove it using the delta epsilon proof. And so here's a graph. We're also going to do this geometrically as well as algebraically. Okay, so let's start with our scratch work. Okay, so again, we want to figure out what our delta is going to be. And again, we start with the fact that we're going to start with epsilon greater than 0. Okay, and so what we need to do, again, just to reiterate, we need to prove that whatever follows is true no matter what positive value of epsilon is chosen. So by starting or stating that we're going to let epsilon be greater than 0, we signal that that is our intent to do so. Okay? So now let's do our scratch work and realize what we need to do is we're going to take the absolute value of x squared minus 4, and we want that to be less than epsilon. Now, here we've got to break this up, okay? Because it's not as easy as the last one. So we're going to have to figure out a way to break this up. We're going to use the definition of absolute value. So that means that x squared minus 4 is less than, is less than epsilon, or the opposite of x squared minus 4 is less than epsilon, or in other words, x squared minus 4 is greater than negative epsilon. Okay, so now, where does this take us? Well, over here we get x squared is less than epsilon plus 4. Over here we get x squared. Well, hold on a second. Do we want to? Yes. Yes. So when x squared is greater than negative epsilon plus 4. And then over here we get what? We get x is less than the square root of epsilon plus 4. And here we get x is greater than the square root of negative epsilon plus 4, or 4 minus epsilon. Okay, so that's where we're at so far. Now, well, what do we have? At this point, we still don't know what delta is going to be. Remember, our delta, remember 0 is less than x minus 2, the absolute value of x minus 2 is less than delta. That's what we're looking for. We're trying to figure out what our delta is. Now, here we know that x, if we subtract 2, so let's do x minus 2 is less than the absolute value of epsilon plus 4 minus 2. And if we subtract 2 over on this side, we get x minus 2 is greater than the square root of 4 minus epsilon minus 2. Okay, so now, how do we get the absolute value? Well, I can make this negative, and this would be then less than, and this would be negative plus, right? Because I'm just going to take I'm just multiplying by negative 1 all the way across. So I flip the sign, this becomes negative, this whole thing becomes negative, so I just distribute the negative sign here. I don't want to do that here because what I'm doing is I'm setting up for the absolute value. Because I'm saying that, hold on a second, let me rewrite this. So this would be x minus 2 is less than epsilon plus 4 minus 2, or the opposite of x minus 2 is less than 2 minus the square root of 4 minus epsilon. Okay, so now, what do we have here? Well, we got two different, we've got 2 minus, so we got this over here, right? And we've got this over here. So now, but these are different. So what does this mean? Well, there's a couple ways of doing this, right? So x, let me fill over here. So just to give you an idea of what we're doing. Okay, so we have x here would be x equals the square root of 4 plus epsilon. And over here would be x equals the square root of 4 minus epsilon. Okay, and that's what we have here. Okay. So x is greater than this, right? And less than this one. Okay. And so I subtracted 2. Why? Because I wanted to get the delta. But now I've got two expressions for delta. Right? Two possible expressions for delta because these are not the same. Okay. So what I'm going to do for delta in this situation is, this is where you have to practice, because in this case here, I don't have an absolute value to deal with, so I'm going to make the delta be whatever the minimum value is, because if we look at the graph, we see that this is the length here, but this goes, let me draw a picture. right? So if we come up here, and we come up here, right? And then just a crude drawing, but this would be 4 plus epsilon, and this would be 4 minus epsilon. There's my band, okay? Now, so the other thing too is I want epsilon, if we go back up here, where is it at? Right here. Epsilon has to be less than 4. Less than or equal to 4. Okay? Because we have this or we have this. Here, if epsilon's positive, we don't care, we just get another positive number. But here, epsilon has to be less than or equal to 4. Okay, and that's okay. So we definitely want epsilon to be less than or equal to 4. Now, you might ask, well, why would we do that? Well, it's okay to make this assumption because, well, why do we want, okay, to answer this question, why do we want this? It's because we can't have negative numbers in the radical, right? And also later on, realize that if we can show that there exists a delta that will make this true for all epsilon that's less than or equal to 4, then obviously it'll be true for all values that are greater than 4. Okay? So think about this. If we can make delta positive, okay, if we choose a delta that's positive that works for epsilon less than or equal to 4, then obviously it will still work for epsilon greater than 4 as well. Okay? Now, it's okay at times and sometimes necessary to put an upper bound on epsilon. But realize that you never want to put a lower bound on epsilon other than 0, right? Because it has to be greater than 0. So just realize that. So here, we want epsilon to be less than or equal to 4 based on this. But also, we have another thing to contend with. Okay, which is the delta. Okay, so what are we going to do? We're going to make delta, then, obviously epsilon has to be less than or equal to 4, right? But also delta, we're going to choose delta to be the minimum of the set of either, let me use this. Let me go back to black. That's better. So epsilon less than or equal to 4, we're going to make delta is going to equal the minimum of what? Of the two values that we came up with. So it's going to be the minimum of epsilon plus 4 minus 2, or 2 minus the square root of 4 minus epsilon. So that's going to be our delta. Okay. Is there anything else I want to say about this? No. Okay, so now let's go back and now put this together. And I'm going to make sure you're taking notes. Okay, so now that we've got delta, we've got an upper bound on epsilon. Now let's do our proof. Okay? So, proof. Let epsilon be greater than 0. And epsilon less than or equal to 4. Okay. And we're not going to lose any generality because of what we talked about before. Okay, so now choose delta equal to the minimum of either the square root of epsilon plus 4 minus 2, comma 2 minus the square root of 4 minus epsilon. Okay. Now we've got that. Okay, now assume what? Assume that 0 is less than the absolute value of x minus 2, the absolute value which is less than delta. Okay, so now let's talk about this for a second. We really don't need this part right here. Okay? Because we know that x can't be equal to 2. Okay? So, let's drop that. So now, what are we going to do? So let's start by just saying, well, the absolute value of x minus 2 is less than delta. Okay? So now what we're going to do is we're going to get rid of the absolute value sign and write this as an inequality. Okay? So in this inequality, since it's less than, we can write this as x minus 2 is less than delta or greater than negative delta. Just using the definition of absolute value. Okay? Now, Let's use the fact that delta, we're choosing delta to be the minimum of these two. Okay? Well, from that, we know that delta is going to be less than or equal to, right? So based on this, we know that delta is going to be less than or equal to 2 minus the square root of 4 minus epsilon, right? And then consequently, then negative delta is greater than or equal to negative 2 minus the square root of 4 minus epsilon, right? We also use delta is less than or equal to, where is it at? Yeah, so we use this one. It's also less than or equal to the square root of epsilon plus 4 minus 2. Okay, so we can also use that here. So now, what does that give us? Well, that gives us, so negative delta is greater than or equal to this, so that means we get negative 2 minus the square root of 4 minus epsilon. Now, we also know that delta is less than or equal to 2 minus the square root of 4 minus epsilon, and delta is also less than or equal to epsilon plus 4, the square root of 4 minus 2. And so the question at this point you might ask is, why did we substitute 2 minus the square root of 4 minus epsilon for delta on the left-hand side of the inequality and the square root of 4 plus epsilon minus 2 on the right-hand side of the inequality? Oops. Well, let's look at the graph here. If we look at the graph, these distances here are not symmetric. And so, in this case here, the one that goes with the shorter distance is the one that we want. Okay? So this distance here is this, and then this distance here is on the right. So if you look, at this one here, 2 minus x minus 4 is right here. Right? So 2 minus is going to be this distance here, right? And then the other one represents the other distance. And we want the minimum distance. Okay, and so what we end up getting is this. Oops. Okay, so this here is what we're using to get this side here and this side here. And so this here, okay, right, corresponds to this distance over here. And this here corresponds to the other distance on the other side. Okay, so let me just repeat that. So 2 minus the square root of 4 minus x, or excuse me, 4 minus theta, right here, represents the distance on the left. And then this one here represents the distance on the right. And so we want it to be in between those two distances. And now if we simplify the expression, on the left, we get negative 2 plus the square root of 4 minus epsilon is less than or equal to negative delta which is less than this, so we can actually just repeat. So this will be less than x minus 2, which is going to be less than delta, which is less than or equal to this. So we can say this is less than or equal to the square root of epsilon plus 4 minus 2. And then of course if we add 2 to everything, right? So we add 2 over here, we add 2 over here, we add 2 over here, then what do we get? We get 4 minus epsilon is less than x, which is less than the square root of epsilon plus 4, right? And if we square all the parts, then we get 4 minus epsilon is less than x squared, which is less than epsilon plus 4. Right? And if we subtract 4 from all sides, we get negative epsilon is less than x squared minus 4, which is less than epsilon. And guess what? Now we're finished, because that becomes the absolute value of x squared minus 4, which is your f of x minus L, is less than epsilon, which is exactly what we wanted. And therefore, we're done. The limit as x approaches 2 of x squared is 4. Now, I took my time with this proof because, one, it is a more complicated proof. It's not as straightforward as the last two that we did. So you've got to sometimes be creative, and you've got to figure out and look at it either geometrically or algebraically. Now, I did it mostly algebraically, but the book does it geometrically, and I did some geometrically as well. But realize that you've got to do your scratch work to try to figure out what delta is going to be. In this case, it turned out to be the minimum of 2 different values. Okay? And then you use that to work backwards. Okay? Okay, other than that, make sure you ask questions. If you have any questions, reach out to me. Also, practice this. Go through this and do it on your own. See if you can figure it out and remember how to go through this. That will also help you too. Okay? Have a great day.